Hey, my name is Andra, and today I will teach my friends some C++ basics related to object-oriented programming that pretty much works for any other language. So, Volga, you can say what do you think about it?
Hi, if I need to be honest, I'm a newbie about objective programming. I know the syntax of loops and etc. in C++, but in objective programming, I'm a total newbie. So, yeah.
Alrighty, so first we'll go through abstraction, later hermetization, inheritance, and polymorphism. And those are the four main things in object-oriented programming. So the first thing is when I, for example, create a whatever class, so let's say bike.
Okay.
This class bike, I can instantly create an object of type of bike, and let's say bike, my bike, and I can have a variable that's an object. And by default, an empty class will have 1 byte of size. That's how it's optimized, because when you have something, it has to take a place in the memory, so the compiler just gives it 1 random byte. But I can, for example, give it a name. So let's say I can include a string.
Okay.
And give it a name. And right now my bike will have a name. And this is the thing about the abstraction is normally every single thing that you will see here, for example, I can change that to integer ID, is just a certain amount of bytes. So for example, this bike is just for now 4 bytes in memory, and those 4 bytes contain an integer, and that's it. But
yes,
it's wrapped in the class bike. But I can add another integer, and let's say amount of years. And right now, this bike will take 8 bytes, and it will only wrap this ident amount of years. But I can, for example, create another bike. Second one. And the second one, right now, will have its own ident amount of years. So every single created object is so-called instance, which means he has its own parameters and functions that are only for him.
Okay.
So if I, for example, create a constructor, so-called, and what constructor is just a function that runs when you create the object. So for example, I can add a parameter int that takes an integer as parameter and sets my ID to this integer. So this is just setting my ID variable to the value of the inID. And after that, I can just print out when the object is created what is his ID. And now you can see that I have no default constructor, and it goes to hermetization, because in object-oriented programming there are 3 keywords that are called public, protected, and private.
Yes.
And for now we'll just go for public. Later we'll cover protected and private. So public means that everything can use that.
Okay.
So right now, if I want to create my bike, since I declared my constructor, I have to also use it, because there is no default constructor. You can also have a few different methods. For example, I can have an empty constructor, and both will work. Because I'm passing no parameters, nothing happens, but I can also pass integer, 2, and this one will call this constructor, and this one will call the constructor without nothing. I can, for example, add another cout to that or whatever. I can do whatever I want. And the whole thing here...
So if a bike has an ID, it calls the constructor which contains...
If I pass the ID to the function,
the
parameter. Because those are just the functions that run when you create the object, so-called constructors. They are used to initialize some values. So for example, I can pass the ID of my bike, but later when the programming is more complex, you may want to give some certain, for example, let's say you have a whole map and you want to declare tiles, so you need to give them some IDs or values or weights or whatever. And there's lots to it, but it's still an abstraction. So I can copy that and actually pass it to this other one, and this one will say that his ID is not initialized. So this one is not initialized, and now if I run my program, you can see that I've got my ID is 2. Let me just make this a bit bigger. So yeah, my ID is 2, my ID is not initialized, and hello world. And the thing is, this first object will now hold in the memory where it's like created. It's on a stack memory, so it's not on heap. And the difference is just one is fast access for the program and it's pretty small, and the another one is just fetching something instantly from the huge RAM memory that needs a lookup and everything. And that's like a simplified explanation, but that's kind of how it works.
Okay.
And now if I want to, for example, take those values, because it's public, I can instantly just say my bike.id and use it to something. Let's say equals 3. And now I can just cout my bike.id. It's just there in the memory, and you can see it's couted 3.
Okay.
Because this instance has 3, but if I use the second one, I will get whatever random number. Oh, sorry, I forgot to add the ID. Yeah. So you can see I've got something, because this is not not initialized integer.
Okay.
And to fix that, I can, for example, say amount ID by default equals 0. So now it will print out 0 because both of them have 0 by default, but the myBike has initialized it to 2 in the constructor and later to 3 in the program.
Yeah, okay.
Yeah, and the next thing is the like protected and private. So let's start with private. What private does is it's making everything under it, because those work under it. Everything that's under this keyword is private, and later if I want to make something public, I need to write public, and then everything under public is public. So now this won't work because I cannot access my constructors, and also I cannot access my variables. And the reason is private only allows you to use those functions and variables only in this object. So if I want to use this ID, I can only do this inside this object and nowhere else. So now the thing that I want to do is to actually make my constructors public, so I can access them anywhere, and make my variables private. So now you can see my constructors can work because they are marked as public, but variables not. And the thing about that is people normally create functions to make sure that the programmer knows what he's doing, that are called getters and setters. So for example, a function that returns integer, get ID, and it just returns ID. And now I can just, instead of IDs, use the getID method, but now it won't work there. It will work with the printing, but I cannot set it because I'm getting totally new value, and I'm getting a copy of value, not exactly the value. So to set it, I need to create a setter. So set ID with integer of new ID, and I can set my ID to the new ID that I pass to the function. So now I can just move it like this, and I will get the same exact result as 2 not initialized and 3. Or if I change the second one to my bike, the my bike will have different values in its instance. It will just print out 3 instead of 0. So that's kind of how the instances work. Do you have some questions so far or anything?
No, not yet. I think everything is understandable so far.
Okay, so the next thing is inheritance, and this is where the protected comes. But first, let's start with creating another class. So let's say this is a fast bike, and fast bike will inherit from the bike itself, and this is how it's written in C++. And this keyword tells me how do I want to actually inherit certain stuff, because depending if it's public, private, or protected, I will have different access to certain things inside this object. By public, I will just get everything the same way defined as in the parent itself. So I cannot use the private, but I will be able to use public and protected. And the way protected works is you can only use it inside bike, so I can only use it there, and also I can use it in childs. So protected is used for this class and also for childs, whereas private will only work for work for the class where it's declared. And also it looks like this. So here I can say float, let's say speed. And now if I have it written like this, I can create a variable fast bike, fasty1, and let's mark this as public. And you can see that in the fasty1 I can still call the get and set ID. And the way it works is pretty much everything from the bike, like this. Yeah. When you inherit, is pretty much written like this.
Okay.
You just don't have the direct access to the private members, but it's pretty much copy and paste.
Okay.
Understand what I'm saying, right?
Yes.
And that's why when we inherit from that, we get every parameter, every method from that. So we can create some basic classes. For example, we can have a class called character, and later in character we can define some basic things like movement, like health, getting damage, getting healing, or whatever. And later we can have a hero, we can have an enemy, we can have a monster, alien, whatever, and they will have their own kind of other implementations. But the base,
same parameters.
But the base will stay in the character, so we don't need to write it all over again. And we just specialize the other classes with the certain thing that they need. And for example, fast bike will need speed, but normal bike don't care about speed because it's some weird game that's where it doesn't matter unless it's a fast bike, let's say. And this is, as I said, total abstraction, what we're doing there. It's just a certain bytes in the memory that we declare to be something, but just so people can understand it easier, we give it like certain names, we say what we can use, what we cannot use, and it's just easier to read and later use.
Okay.
So it's also like important to use the proper names, so later you know what's going on and not XYZ.
Yeah, okay.
Yeah, so like this you can see that I can have, let's say, protected here, that will do as int special ID, and the special ID pretty much can be taken right here, so speed equals special ID, and I can just use it like this.
Okay.
And now since I'm not using it anywhere, you can see my ID is not initialized because I'm creating my fast bike again, and it's another one that calls the constructor that is not initialized. And that's like the basic how those three works: abstraction, hermetization, and inheritance. We can later inherit from different like classes. For example, I can have class C, and it inherits from public fast bike and also public bike. I can do that. I can inherit from as many classes as I want to. I can even do it at compile time with different things. So just, you know, that's not like limited to one class.
Okay.
So people just create the so-called interfaces with certain mechanism that can be reused in different places, and they have like no implementation, or just have some virtual functions that we'll get over in a moment, because there's also the polymorphism. And the first thing that was a polymorphism that I actually used was those two constructors, where one function takes an integer and the other one does not. And I can have also or kind of it where the set ID takes actually a float and does conversion to integer. Therefore, if I, for example, use set ID and pass a float, then I will run this function, but if I use set ID and pass an int, I will use this function.
Okay.
And that's like pretty much how it works with it was so-called static polymorphism or whatever. I don't remember the names, but it doesn't really matter. The thing that matters is I can, for example, have an object. I can right now say that the second one equals fasty1. And again, this whole thing is just an abstraction under the hood, where I'm just saying that parent object equals the child object, and we can still use its functionality, or we can still cast the parent object to any of its child object that we have, because the compiler actually knows how it will look like and how to set everything up. So, for example, in the second one, right now, because it's bike, I won't have the access to speed, as you can see. But if I do the... if I just want to use the fasty one, I can instantly access speed. And I can later do an fast bike 2 equals second one. And I just need to do a dynamic cast to that, or even not dynamic, the static. Oh yeah, and also I need to define a function for that. So yeah, it doesn't matter for now. I just ignore that because I don't want to go that much into C++. Pretty much when I have methods in objects that are equal something, in this case where I had to implement that child equals parent, I will need to actually implement the methods right there. So operator equals, and then later implement everything, so on and so forth. And that's pretty much, you can override most of the operators. For example, this those arrows from the cout are just a function. You can see operator arrows. It takes a certain value and then it does some logic for the stream.
Yeah, okay.
In the OStream file, as you can see. Every operator is just a function. This dot is also a function that allows you to use a certain parameter from this object. I will not go into pointers and stuff from C++, but mostly in the polymorphism, you have to remember that you can have this object called bike, but later you can just inherit from that and have bikes that use the implementation from the basic bike, but they actually have their own specialized stuff that is only for this certain class to use. So we are not rewriting the code for the base, and it can be used anywhere. It can be some shapes, it can be some animals, it can be people, it can be buildings, it can be like weapons, anything, where we just declare the base and later just inherit from that. So we can just use it in a specialized manner. Or for example, just use it as interface. A simple example from game dev is an interaction system where you can just define a class. Let me just call it IS. And you just say that there is a, let's say, function interact. Like this. And just for the purposes of this video, if you want to learn what virtual does, it's pretty much creating under the hood pointers to functions that are in the lowest possible place to call. So for example, if I make my getID virtual and I make another getID over here, sorry, not here, but here, I don't have the access to ID. Well, there's specialized ID, let's say. Then, if I call the getID on fastbike, I will get the implementation from fastbike, and if I call it an object of bike, I will get the implementation of bike. But there's a catch that if, for example, as you can see, I have this second one equals fasty1.
Okay. Yeah.
And so now if I say second one get ID, the result is 0, while the, wait. And yeah, because in both cases it's not initialized, so let me just initialize that. Here it will be 5, here it will be 1. Alright, and it takes no parameters here. Alright, and you can see that it's still 0 because I just got the value from the fasty one to the second one. So wait, I just brain lagged. What I wanted to show you. Let's just start with other function. Let's say void print let's do it like this, where I'm just taking any object and just printing its ID.
Okay.
And polymorphism allows me to actually take as parameter any object that's bike or an object that's inheriting from bike. So for example, I can say print my bike, but I can also say print fasty1. And here I will need to either convert everything to pointers or, yeah, oh sorry, yeah, like this. So yeah, I forgot to add spacing. So they're created. Later I'm printing stuff, and it's printing of my bike, which has 2as ID and a random number because fast1 is not initialized.
Yeah, okay.
But as you can see, I passed objects of different types to this function. It works on every single one of them.
Mhm.
And I can also here print out that I'm actually getting the ID of the fast one. So fast implementation. And something went terribly wrong. Okay, so I've got my fast implementation. So as you can see, I'm calling, the first one is called for the ID of the normal bike, and the other one is called for the ID of fast bike, even though I'm passing an object of bike, which has no implementation of this fast implementation. And later you can do some, I mean, this is like the proper way to program things when you work on objects. So for example, you can have some people, and for example, you can have deal damage, and you don't want to create a function that deals damage to demon, that deals damage to fucking goblins or whatever, but you just want to say character dot take damage, and it works on any character, and in its character you get its own implementation of take damage, where a demon in itself will know how much damage he can take from something, but here you just want to deal damage to any character, and that's it.
Okay.
And it doesn't matter what you pass to the function, it just has to inherit from this class. And that's like the basis of how polymorphism works. And the virtual works in a way that the first thing is you create a pointer, and what a pointer is, it's just an address to a certain memory location. And it's creating a pointer to a so-called vtable, which contains other pointers to functions. So for example here, here I have a pointer to a vtable that contains a pointer to this function, and that's pretty much it because I don't have any other virtuals. But I can, for example, have this as virtual, and I will also have this pointer here, and I'll have this v pointer so I don't get the naming fights over there. And this v pointer will point to this function, whereas this pointer will point to this function if it's called from the object of fast bike, and also to this function because set ID is the highest, I mean the lowest possible in the hierarchy function that you can call from that. You understand what I'm saying, right?
Yes.
So because here's the override of get ID and it's the lowest, I will call it, but for the set ID I will call it right there. And therefore this pointer points to this get ID and this set ID, and this pointer points to this and this.
Okay.
And when you just use those objects with the virtual methods, so you can do some polymorphic stuff that makes your life way easier. What you're doing under the hood is actually looking up the vtable, choosing which function to call depending which one is the lowest possible, and then calling it. And that's why if you, for example, have this bike object that, for example, I just passed there, and you pass an object that is 6 or 10 or whatever amount of classes lower, which is kind of a lot, but let's say 3 or 2, then it will look up the lowest possible function and then call it. And that's like the basic of object-oriented programming. And like, do you have any questions related to that?
Could you explain me once again what does protected do?
protected allows you to use it only in this class and
Okay.
also in the child's, so in everything that inherits from this class. Because
Okay, so the difference between protected and private is that the private works only in this class, and protected could be given to the child classes.
yeah.
Okay.
When it's
And-
public, it can be used anywhere. When it's protected, only here and it's child's, and when it's private, only here.
Okay.
And those are the rules, and that's it. And
Okay.
later, what you care about is how to make a base class that has the most basic implementation that I can use anywhere, and later just inherit from that in other classes. Wherever
Yeah,
you
yeah.
want, whenever you can use virtual. Well, if you're doing some really low-level programming, which I guess you said that you've been doing some Python, so you don't really care about that, but
Yeah.
virtual is a bit slower than normal functions because you have to look up the vtable and later call this function nada, and also you have this pointer which is adding the size of pointer to the function.
Mhm.
Therefore, you might care about that, but if you do it in Python, then you just write virtual and you don't give a shit. Like,
Okay.
that's not a problem or anything for you. Yeah, and you also need to remember that those are instances. So, for example, I can have an. Let me just include a vector. I can have a vector of bikes.
Mhm.
And let's say, let me just, I want reserve memory because it's just for tutorial purposes. Actually, I do that. Let's say I just reserve for 3 of them.
Yeah, okay.
And here I can just say my vec dot pushback, and I can just move that here. Can I do this like this? Yeah. So this is the first one, the second, fourth. This should be done in a loop or whatever, but I'm just doing this to show you something.
Yeah, okay.
So here I have 5, and here I have a fasty bike. And fasty bike takes no integers. Yeah. And now if I want to, for example, print, I need to get my vec dot. Actually, I can just do 0 dot. And that's it, actually. My vec 0. Fasty one was the third one, so it's 2. And yeah, that's like pretty much it. And later I can also use that and use that. And I'm working on my vector, and I can have many different instances in the many different instances in the memory of those, and every single one of them will have its own parameters. So for example, if you have a whole city with many citizens and everyone can fight, then each one of the citizens will have its own health, like statistics, like evasion, armor, damage, attack speed, so on and so forth, and it can be unique for each one of them by just randomizing it, for example. And the thing to remember is that when you work with objects, every single one is a different instance, and they don't, I mean, they can share certain things because you can have a static stuff. Let's say you can have amounts. Alright, you have to do this like this, and later I can declare it that you can increase the amount each time. You can, for example, move it there and increase amounts each time I just create something with the past integer, and this static will be shared. I can just move it there, and later I can just get it. And how it works is pretty much by taking, let's say, second one dot amount, and that's it. And the amount will be shared between every single byte, because statics have their own place in memory, but everything else is different for the instances. And do you have any other questions?
No, I think not. Everything is clear.
All right,
Of course,
great.
Of course, I need some practice, but it's good for start.
So I might have made some mistakes when I tried to cast there, but I'm kind of tired and it's whatever for me. But I guess that you understand it from this example with this get ID of bike.
Yeah.
And also the instances and stuff. So I will leave it for now. So thank you for coming, and that's it.
Yeah, thank you. Thank you very much.
Cheers.